So let's have a recap of whatever we've learned in Trigo quickly, very quickly, children. First and foremost, we learned that sec theta is 1 upon cos theta. Cosec theta is 1 upon sine of theta. Tan theta is 1 upon cot theta or sine theta upon cos theta. It will also make cos theta upon sine theta as cot theta, which is equal to 1 upon tan theta if we work backwards. Also, identities, children, we know, we should remember by heart, is sine squared plus cos squared theta is equal to 1. 1 plus tan squared theta is equal to sec squared theta, and 1 plus cot squared theta is equal to cosec squared theta. Now children, also you must remember, as a basic rule for all the identity sums, it always works if you convert everything in terms of sine or cos, or we keep the identities in mind and simplify it from left hand side to come to right hand side. Let's see a few examples, quick ones, to come to that concept thoroughly. Like a question says, prove that root of sec squared a plus cosec squared a is equal to tan of a plus cot of a. Simplifying this, children, we'll take the left hand side to simplify. That's left hand side, specify that please. Root of sec squared. Now sec squared theta we know is 1 plus tan squared theta, and the reason why we do this is because we need the answer in terms of tan and cot. So we'll use sec squared as 1 plus tan squared, that's 1 plus tan squared a, and cosec squared is 1 plus cot squared, so 1 plus cot squared a. Now children, this will give us root of tan squared a plus cot squared a plus 2. Now children, to make it a perfect square, since we need to remove the root sign, there is no root sign. To remove the root sign, children, will multiply and divide by tan a, that's tan a times cot of a. So tan a times cot of a is 1, tan a times cot of a is 1, that's root of x squared plus y squared plus 2xy, that's root of tan a plus cot a, the whole square, whose square root would give you tan a plus cot a. So children, here we simplified the left hand side to come to the right hand side, and we got the answer, children. Need to remember over here, children, if the identity works directly, then we don't have to use anything else. We can just simplify it, come to the answer. But if it doesn't work directly, we may rationalize in some sums, we may use rationalizing in some sums, or we can convert into sine and cos. Let's see, for example, a sum like this. 1 upon cosec a plus cot of a is equal to cosec a minus cot of a. Now children, here we can simplify the left hand side. Again, we're taking the left hand side, so let's rationalize it. So cosec of a plus cot of a, that gives us rationalize, so cosec a minus cot a, cosec a minus cot a, multiplying over the same term. Children, the reason being from here 1 is the value of cosec square theta minus cot square theta. Cosec square theta minus cot square theta is 1, which is what we'll get over here in denominator, children. So we'll get cosec a minus cot of a upon cosec squared a minus cot squared a, which is 1, children. So we get our answers cosec a minus cot of a, which is the required right hand side, hence proof, children. So these are tricks, these are the important ways of doing identities, Trigo identities sum, children. Let's see another example in which if you convert in terms of sine and cos, the question will become easy to solve. Something like, the question says, children, sine of a upon sec of a plus tan of a minus 1 plus cos of a upon cosec a plus cot of a minus 1 is equal to 1. So again, children, here we'll simplify left hand side, converting everything in terms of sine and cos. That sec is 1 upon cos, tan is sine a upon cos a, And same thing we'll do over here, children. Cos A 1 upon sin A plus cos A upon sin A minus 1. Which gives us, children, we take LCM as cos A and bring it up. So we get sin of A into cos of A upon 1 plus sin of A minus cos of A. Plus, again here, children, we get sin of A, cos of A. Taking the LCM as sin A, 1 plus cos of A minus sin of A, children. So now, children, again we'll have to simplify this. We can take sin of A into cos of A common to give us 1 upon 1 plus sin A minus cos A plus 1 upon 1 plus cos A minus sin of A. Now, children, taking that as LCM, we get sin of A cos of A. To multiply both the terms, children, to give us 1 plus cos A minus sin A plus 1 plus sin A minus cos A. And denominator will multiply, children, that's 1 times 1 plus 1 times sin of A minus 1 times cos of A plus cos A times 1 plus cos A sin A minus cos squared A minus sin A minus sin squared A plus sin of A cos of A, children. Now here, first of all, sin A cancels, cos A cancels. Now here, children, minus cos A will cancel, minus sin A plus sin A will cancel, cos A sin A plus cos A sin A will be 2 sin A cos A. So here also we have 2, children, so that's 2 sin of A cos of A upon 1 minus, if we take common between these two, children, minus, that's sin squared A cos squared A, and the other thing would come out to be 2 times sin of A cos of A. This, children, sin squared A plus cos squared A is 1, so 1 minus 1 is 0, and then we're left with 2 sin of A cos of A upon 2 sin of A cos of A, which cancels to give you 1, children. So here, this is the required right hand side, hence proved. So, children, here what we've done is we've converted everything in terms of sin and cos, simplified to come to the final answer. So that's the important thing, children. For Trigo identities, we can convert everything in terms of sin and cos and simplify, or rationalize if the sum asks us for the same, or we just need to simplify using the identities to come to the right answer. Let's see complementary angles. In case of complementary angles, children, we must remember it goes like this. In any given triangle, if angle A is theta, this is 90, by angles of a triangle, this would come out to be 90 minus theta. And the relation would come out to be, children, sin theta is cos 90 minus theta. And vice versa, that's cos theta is sin 90 minus theta. Tan theta is equal to cot 90 minus theta. Children, for tan and cot, they are reciprocal as well as they are complementary. They are reciprocal as well as they are complementary. And last relation we have is cosec theta is sec 90 minus theta. The values come out to be the same, children. Now let's see if let's see a sum where we can apply it easily. Like a sum, a question says, without using tables, find the value of cos squared 20 minus sin squared 70. So, children, here we change it like this. We change either cos 20 or sin 70. I'm going to change sin 70. Sin 70, children, sin 70 is cos 90 minus 70. That's cos 90 minus 70. Which, children, comes out to be cos squared 20 minus cos squared 20. Children, to give you the value as 0. A very simple sum like this, children. Very simple sum. Let's see another example of the same type. They want us to prove, find the value of, cosec squared 58 minus tan squared 32. So any one of them we can simplify, children. Let's simplify cosec. So cosec complementary, children, is sec. So that becomes sec 90 minus 58 whole squared minus tan squared 32, which will simplify to give us sec squared 32 minus tan square 32. Now the identity, children, we have is 1 plus tan square theta is equal to sec square theta. So sec square theta minus tan square theta gives us 1. That's the value, children. They ask us to find out the value without using table. So this is as far as complementary angles are concerned. In heights and distances, children, heights and distances, remember, they'll always give us where the person's there, the horizon of the person. And then if he sees up, it'll be angle of elevation, children, like a bird or a plane in the sky or a cloud. It's going to be angle of elevation, which will be with respect to the horizon only. And if you see something down, it'll be angle of depression, children, like this, which will be with respect to the horizon again, which is always parallel to the ground. Buildings and towers and poles, all ships, all planes, all perpendicular at a certain instance to the ground. They'll always be perpendicular, children. So this marking perpendicular is very, very important, because you cannot apply Trigo if there is no right angle triangle. Trigo can only be applied in a right angle triangle. Otherwise it cannot be applied, children. Well, this is angle of elevation. This is angle of depression. To depress, to look down, to depress the eyesight, to look down, to elevate, to look up, to elevate, to look up. Children, remember that. Please do not confuse yourselves with that. Right angle triangle is extremely, extremely important. Also, children, you must remember that we will need to rationalize in a few cases. Also, we have to use the Trigo tables from behind or a logbook which will be given to us in the school. Use values from there and simplify. Let's see a simple example based on these kind of questions. Question says, shadow of a tower when the angle of elevation of the sun is 45 degrees, is found to be 10 meters longer than when it was 60 degrees. Find the height of the tower. So children, what we have been given is shadow of a tower. Children, elevation of the sun with respect to the ground is this angle, children. Elevation of the sun with respect to the ground is this. This is the ground level. And the angle of elevation, children, would come out to be this. So this is 45 degrees and this is 60 degrees. The greater angle is here, children. The greater angle is here as compared. This is the bigger angle, children. This is the bigger angle. That's 60 degrees here. This is 10 meters. This is X and this is Y, children. They want the height of the tower. We'll name the triangle that's A, B, C and D. Now children, in right angle triangle ABC, tan is the most appropriate ratio which you're going to use, children. Very rarely will it be sine or cos. Very, very rare. Mostly going to be tan, which is opposite upon adjacent. Tan 60, children, need to remember from the Trigo tables what we learned last year. Tan 60 is root 3. So root 3 is equal to x upon y, or x root 3 is equal to y. Now children, the second triangle we'll get in right angled triangle. ABD. Tan 45 is equal to opposite upon adjacent, that's 10 plus x. Tan 45 is 1, so y is equal to 10 plus x. Now children, here we need to find out the value of y, so we will make x subject to the formula. We will make x subject to the formula here. So that will give us y is equal to 10 plus y by root 3. We'll bring both the y's together. That's y minus y by root 3 is equal to 10. Take y common, children, we get 1 minus 1 by root 3 is equal to 10. That gives us y is equal to 10 times root 3. upon root 3 minus 1, which we will rationalize, children. We need to rationalize, children. Please remember that we need to. It's a compulsory step. We need to rationalize it, children. We cannot leave it unrationalized. Or we cannot divide it or substitute the value of root 3 is 1.732 and simplify, children. That will not be acceptable. Rationalize it, please. It cuts your calculation down a lot, because a plus b into a minus b is a squared minus b squared, which is root 3 squared minus 1 squared, which is 10 times 1.732 into 2.732 in this particular example, children. That comes out to be 2 cancel this to give us 5. So the answer becomes 5 times 1.732 times 2.732, which we will multiply, children, to come to an answer of 23.66 meters, children. So children, here we have seen a few examples of how trigonometry should be attempted. We should try to draw a diagram first and foremost for heights and distances, draw the right angle, triangle, name the relevant thing, then most likely it's going to be tan, in some rare cases it's going to be sine and cos. That's a simple thing for Trigo. Thank you.